Okay. I think I'll get started. Thank you for having me here. It's a great pleasure. Can everybody hear me okay? Yeah, that's all right. So I'll be talking about a comparison between two kinds of information, speaker gaze and action information. So I'll be taking you on a very different journey from the previous talks. Before I get into the details of the talk, I would like to highlight that the work that I'll be reporting today has largely been executed by Helene Kreisa, one of my former postdocs in the group. She's now in Jena in Germany, and by a master student in the group, Eva Nunnemann. And thanks also go to various funding sources. So, since we are shifting topic, I've included a slide here to just broadly situate you regarding what we do in the group. We're looking at how people integrate non-linguistic visual information during spoken language comprehension. You could see a range of different things in our experiments. For instance, on the left here, a speaker looking at a computer display, shifting gaze in response to a spoken utterance, and we track their eye gaze, where they look in response to the speaker's gaze and in response to the language. In another experiment, people could see cards turning and read sentences about those cards. They could hear spatial language in relation to objects that are depicted. They could see an emotional facial prime and then a valence sentence, and we look at how do they relate those two. In all of those cases, we'd be tracking eye movements or measuring event-related brain. Your speaker shift gaze from, say, the middle character to one of the outer characters. Seeing an action between the two characters could facilitate in addition to just seeing the speaker's gaze. Or you might hit a certain level of complexity, and if so, two cues may not be better than one. And this is what we are going to be looking at in our study. So in terms of the materials, we are going to be using Second Life characters, fabricated in Second Life, and snapshots of 3 characters, accompanied by 24 sentences describing actions between the characters. So something like, the waiter congratulates the millionaire outside the shop. The waiter would be the middle character here, and the millionaire, the one on the right. We've taken videos of the speaker describing these sort of Second Life scenes on a computer screen. And at the verb, crucially, the speaker shifts attention from the first mentioned character, the agent, here the waiter, to one of the outer characters, the millionaire. Direction of the gaze shift and also the position of the characters has been counterbalanced. The timing of the gaze shift was modeled on existing production evidence, and we tested that people could detect the gaze shift. So just to give you a bit of an example of what this looked like. So what you've just seen is, it's okay, I'll fake it. You've seen the speaker look around. I'll just play this again. You see the speaker looking around to the 3 characters in a fixed order. Then she looks back at the middle character, and then she starts to describe the waiter, congratulates soon the millionaire. So during the verb, she shifts her gaze from the middle character to the millionaire here. So that's sort of the basic setup of our stimuli, and we combined that with tools that we presented. We had 24 tools associated with the verb of the sentence. Those were rated, ensuring that people could recognize it accurately and that they were a good match for the verb. So for instance, congratulate would be represented by a bunch of balloons, to assault would be represented by a pistol. And those tools would appear between the characters that you've just seen, and an example would look as follows here, where you see the balloons appearing between the waiter and the millionaire, and the gun appearing between the waiter and the saxophone player. All right. we conducted 2 experiments with the setup. One where just one tool appeared between the first named and the second named character. And the experiment manipulated 2 factors within participants and items, gaze cue and tool. And a second study where we had 2 tools appearing, one that matched the verb in the sentence and that appeared between the first and second mentioned character, and a mismatching tool that appeared between the first mentioned character and the competitor, the other character here. This was done to avoid a pop-up effect because, when the tool is sort of appearing, people automatically zoom in and focus on the tool, and we just wanted to make sure that we also tested with 2 tools. Our critical dependent variable is the gaze shift of the listener to the patient character. So in a sentence such as the waiter congratulates the millionaire, looks to the millionaire, following the speaker's gaze shift and following the appearance of the tool are our dependent variable. The appearance of the tool was time locked to the onset of the speaker's gaze shift, so there was no difference in when those 2 cues appeared. In terms of the trial sequence, people first saw a drift correction dot centrally presented. Then they were presented the video, they watched and listened, which was their task. The speaker was either visible or obscured behind a gray bar, and the tools either appeared or they did not appear. During that time, we recorded participants' eye movements. Post-sentence, there was a response template, and we asked participants to respond whether the role relation depicted between 3 stick characters, and each of these figures matched one of the positions of the characters in the video, and participants knew that they were supposed to relate the stick figures to the characters. So they were supposed to say, well, does the action direction indicated between these stick figures via an arrow correspond to what we've heard in the sentence? And congruency was counterbalanced in the experiment. We measured response times to this template. Post-experiment, there was a memory recall test, and I'll be saying something about how that happened later on in the talk. All right, now to the results. What you can see plotted here is proportions of fixations to the target patient, so the millionaire in a sentence such as the waiter congratulates the millionaire, in the 4 conditions. So we have a gaze plus a tool, the gaze only, tool only, or no cues are available. What you can see here, the red line is the gaze-only condition. It elicits the steepest anticipation of the patient character. Then you can see a dip for the purple and the blue line. Those are respectively the 2 cue condition and the tool-only condition. And you can see the sort of dotted line in black, that's the no cue baseline. You can see the dip for the conditions where a tool appeared comes from the fact that the tool actually attracted attention. So to the right, I've plotted fixations to the other regions, such as the tool, the speaker, and the background. And you can see a big rise here at the same point in time when we actually see a dip in the other graph, such that it becomes clear where that dip comes from. So those are the data from experiment 1 when we had 1 tool appear. What is clear here is that gaze had an effect. The red line is clearly a steep anticipation of the patient. And I should say what's plotted here is from the onset of the speaker's gaze shift across the ensuing sentence. Now in experiment 2, you see a very similar pattern. You also see in red the gaze only condition, fixations to the patient leading to a steep rise of anticipatory looks, followed by the gaze and tool condition and the tool only condition, and the baseline being sort of initially quite high up here, but then actually slowing down. The reason why the baseline is a bit high here is because people actually looked back and forth between the 2 outer characters, trying to decide which one, and there was no cue that could inform them. Now, we analyzed eye movements in 2 time windows statistically. One first time window immediately following the speaker's gaze shift, and a second time window during the second noun phrase, so from 200 milliseconds into the second noun phrase the millionaire. And what you can see here is a summary of the results for the first time window, so the shift time window immediately after the speaker's gaze shift. As I've already described, oh, and I should say, you've seen here, you've seen here proportions of fixations. In the analysis, we actually used a different measure. We used log gaze probability ratios. The reason why we did that is because looks to areas on the screen aren't independent. So we need to kind of be a bit careful in our analyses and use a different measure. And I don't have the graph for that right now because actually the first author of the study, Helene Kreiser, got pregnant and the baby came before she could make the graph. So I apologize. I just don't have that yet. I do have the inferential statistics though. Yeah. So, but you'll see that in a couple of places, the results from the inferential statistics don't quite match with the proportions, which is because we've used a different measure. So what became clear in the inferential statistic is that people anticipated the patient more than the competitor, and the measure we're using here is how many looks do we get to the patient, the millionaire, compared to the saxophonist, right? If they look 50-50 to both of these characters, the ratio is 0. If they look more to the correct patient, we get a sort of larger number. So more looks to the patient than the competitor, which is good. We also get more looks to the patient when the speaker's gaze is visible than when the speaker was obscured, and this in both experiments. In experiment 1, when there was only one tool appearing, participants anticipate the patient more than there was no tool, when there was no tool appearing. And this effect didn't come through immediately after the gaze shift in experiment 2. Gaze and tool did not interact in experiment 1, but it did interact in experiment 2, such that the gaze-only condition yielded more anticipation of the patient. Excuse me, I'm not feeling quite well. Such that the gaze-only cue condition led to more anticipation than both cues, or the tools-only and the baseline condition. Okay, I'm really not feeling well. Sorry.
Can we open the window? Is it sugar?
All right, I apologize. I sometimes get that when the air gets bad in rooms, so yeah, sorry about that. All right, let's see, where were we? So, yeah. All right, thanks for catching me. All right, let me wrap this up. So people anticipated the patient. They did so more often when the speaker was visible than when she wasn't visible, more so when the tool appeared than when it didn't appear. And critically, let me stress that both cues were not more helpful than only the gaze cue, and definitely not more helpful than only the tool, especially not in experiment 2. Let me go back here. You can see clearly here the tool-only condition is the blue line. It's the lowest in anticipating the patient and lower than the gaze and tool condition or then the gaze-only condition. Okay, I'm going to skip this and get right to the post-comprehension test, where we did a gating study in which people were prodded to remember parts of the sentence. They saw first the first noun phrase and no, this isn't good. Yeah, I think so. I'm really sorry.
If you want to continue or not, you're okay. So that's not I like that curvy shot. Так, а что будет наше действие? Should we call it? You will understand it. But you said you don't. It's easy. Yeah. I'm so sorry. You should. Please.
No, I think I'm okay. All right.
You can just sit a little.
Yeah. All right, third try. If that doesn't work, I'll give up. yeah, like I'm on the last slide, so thanks for bearing with me. So in the skating paradigm, participants saw first a noun and an accompanying picture to prod their memory, and their task was to remember the verb. That was indicated by a sort of underline. Here you can see the paradigm presentation in the upper right corner of the slide. If they couldn't remember the verb, and this was not an easy task, I should add, since there were quite a few items to remember, and there were no stereotypical associations between the verb and the patient and agent, so people had to rely purely on what they had seen and heard in the experiment. So they were prompted by the tool for the verb. Then if they didn't remember that, they got the verb, and then they got a blank and were prodded for the patient. If they couldn't remember it by themselves, they got a choice of 3 depictions. One was the correct patient, one the competitor in the item, so the other outer character, and the third was a character from another experimental trial. And what we wanted to see here is how well could people remember the patient and the verb as a function of the experimental conditions. So whether they had seen both cues, the speaker's gaze shift only, the tool appearing only, or no cue. At the verb, recalling was very low, but when they got the correct tool, they could remember the verb at least on 30%. At the verb, the recall of the patient was very low, but when they got the selection of 3 patients, they were actually substantially above chance, and interestingly so, this differed as a function of the condition. So when they had seen the tool only, they were at 60% in recalling the correct patient, and that was more than when they had seen either no cues or the gaze only, which dropped to 48% recall from 60%, and worst for both cues. So in sum, what seems to happen here is that gaze is a very efficient cue online during the sentence in guiding your attention to a correct target that will soon be mentioned. It's not too surprising, since there is a robust link in how speakers refer to things. You know, they tend to shift attention to things just before they mention it. The action was way less effective during the sentence in shifting attention to the target patient, but eventually, with some delay, the action also had that effect, which replicates existing findings in the literature. What was very interesting, though, is that post-sentence, the action bound the verb and the patient, especially the patient, much better into your memory than just seeing the speaker's gaze. And what this is sort of contributing to the literature is that we may want to consider the type of cue that people process in predicting how visual attention and language comprehension will unfold from stimulus presentation to a response and also later memory of understood content. Thank you, and thanks for bearing with me.
Questions, please. Go ahead. You're the first.
Thank you for the talk. It was really very interesting. The question is, did you compare different tools? Because there is a famous weapon focus effect, which draws attention to any weapon like gun or something like this. Isn't the drop just due to this effect?
Mm-hmm. So we had a range of different tools, 24 in total. And so the gun was one example. It wasn't such that they were always violent or particularly salient. Yeah, but that's a very good question. Yeah.
More questions?
I have a speculative question. So there is a different kind of gaze that people use when communicating, such as lifting their eyes up when they're trying to remember something and then moving them different direction, whether they're sort of thinking of the future events, which seems to be a regular phenomenon. Would that influence understanding between the communicating
So you mean
agents?
if our speaker were to sort of briefly
Yeah,
cast
if
her
the
eyes
speaker would
upward?
be to do something like that, as if she has to remember something.
Well, I mean, we are possibly, right? I mean, it would certainly probably draw more attention to the speaker herself. Right now, participants actually seem to process the speaker peripherally, so there are very few inspections to the speaker at all. Throughout the sentence, she's only looked at before she starts to speak. And so I imagine if there's either more direct gaze contact between the speaker and the other interlocutor, the listener, or if the speaker in any other way, diverts from her usual regular referential gaze pattern to sort of looking upward, then more attention would go to her directly, similar to more attention, being directed at the tool when it appears, and that could very well delay these anticipatory eye movements that we see now so spot on. Yeah, interesting question.
More questions? Yes.
Yeah, and for the interruptions.
Yeah. Things come with entertainment. Right. So during the shift, you have this dramatic dip for the tool conditions. Mm-hmm. Would you go as far as to say that, I mean, if you go to a higher level of abstraction, if you want, that communicative cues are more valid than, or interlocutor-based cues are more valid than semantic or pragmatic cues that can potentially do similar work?
More valid.
Or,
what do you mean
stronger,
by
for example?
Stronger.
Or
So I think they affect
high
processing
priority.
very differently, right? I mean, if you have a tool appearing that needs to be semantically processed, like it has to be integrated with the verb, especially, so we had two experiments, one where only one tool appeared and that always matched the verb. And in fact, just seeing where the tool appeared, independent of what was depicted, would sort of be a cue to the patient, right? But when in the second experiment we have two tools appearing, one matching the verb, the other not, that clearly requires deeper semantic processing of the tool itself. That may take attention and time, and that could very well lead to the delay that we see during online processing in guiding the listener's attention. But then also motivating the improved recall that we find post-sentence, right? Because the verb is bound to the action, and so cues the patient in a different way than the gaze cue, which is not sort of lexically grounded in the same way.
It's more easily available then, rather than hierarchically more important.
Possibly, yeah. Mm-hmm.
Thank you so much. You have earned your cup of tea for your courage. The next presenter